Hi, hello everyone. Last time we left off with basically these sprites, and I mentioned that I'm going to fix frame rate, which is now buckling. It's not even that bad, but what we're doing actually is bad, and I'm going to show it in a second. So for sprite rendering, let me just lower this to 10 and 10, because otherwise it might get messy. So if I bring my WebGPU debugger, and maybe I just need to reset it. Okay, now it's collecting the data. So we're going to see the data here. If I open one of the frames which is captured, you're going to see these draw calls here, right? And that's the reason for our performance issues, which we don't have now because we're not drawing a lot of objects anymore, but each of these is one call to an object. And how do you do sprite batching? Well, the sprite batching isn't that hard, and I'm going to explain it in a second, but the whole idea is to actually have all of this call and have them as one call with larger memory, so that it's not drawing so frequently. So how do we do that, and how does it look like? Well, let's see. If I bring my tool, famous drawing tool, and if I maybe comment this out because it's bothering me. Oh, not delete it. Oh, what is happening here? Ah, wrong button. All right. If I do this, right, we have so let's say this is our frame, our whole frame. And so our objects are drawn like this. So this is one, and then it's drawn to the screen. Sorry, it's drawn to the back buffer texture, which is our final texture that we present to the user. Sorry, that we present basically to the canvas. So then we draw the other one, then we draw the other one. So all of these are drawn one by one. But how does sprite batching works? Well, actually the idea is, so imagine that this is not drawn yet, this is not drawn yet, this is not drawn yet, it's not drawn yet, it's here. But sprite batching will work like this. It will draw all of this at once instead of doing this, right? Then presenting, then this, then presenting, then this, then presenting. Anyway, you get the idea. So the idea is just to batch calls. To batch means to, well, push something in a batch. So we're going to do that. But before we do that, let's actually, I don't need this anymore. So let's actually just refactor our code a bit, because this might get messy, and we'll see how it goes. But for starters, what I'm going to do is create a small class. Actually, not that small class. It's going to be called Sprite, Sprite renderer, and then we're just going to export it as well. So what are we going to do with Sprite renderer? So we can bring these guys back, and then I'm going to pull all of the data from here, or at least most of it, into the sprite renderer where it makes sense. So the first one where it makes sense is this draw sprite function. So I'm just going to copy that, and then I'm going to move it to sprite renderer. Okay, we see here that we need sprite pipeline. Let's resolve sprite pipeline. We need to have vertex data, so I'm going to pull vertex data as well. Let's see. Okay, that fixes it. We need to resolve these imports. We need device. So it's going to have a constructor, and we're going to say private device. I just know it, but we're probably going to need to have width and height, which is of type number, private height, which is also of type number. We're going to need that. Then let's see. Further, we're actually, this can remain here, this can remain here. We're moving these two guys, and we're going to have initialize. So let's move that, this projection and index buffer. So we had here projection, index buffer. We're going to move vertices buffer as well, and the camera. So you can copy that and then move that here. This format. Let's solve this. We need to import our camera. So in our main, we had camera here. So now it's going to, we can just initialize it here. And then we can get rid of this. We don't need it. So we're just going to paste this with this height. What else do I need to refactor? So let's see. This won't be here anymore. So let's just move it here for now. We're going to deal with that later as well. This is okay. And then we're going to create sprite renderer here. And we can initialize it somewhere over here. We need this device, this canvas width, and this canvas height. Let's just call this initialize. And we're actually going to draw without sprite render. So this dot. And here as well. So that's it. And we still have issue here. We need the pass encoder, so we can just create some small function which is going to be called frame pass. And we're actually going to pass this pass encoder. So let's just see in main. And here we're actually just going to copy it, not actually cut it. So we can have pass encoder and here. So let's just do this. GPU render pass encoder, and we can just set it so that it's available to us. If I save it, it's not working for some reason. Let's see. Did I forget anything? Here are sprite render, we have pass encoder. It should be working. Yeah, refactoring. Set pipeline. I missed somewhere the pipeline part. I have sprite pipeline, then I have moment. No. Aha, vertex buffer. We're actually creating it here. Aha, we never called frame pass. Oh boy. So yeah, that was easy. A bit lost here. So let's just say, we can say over here this sprite render frame pass, this pass encoder. And now it works. Perfect. So that's it when it comes to refactoring this. So further, we actually need to start working on our sprite render and make this batch calls possible. So how will our batching work? Well, it's not that complex, and I'm going to explain it in a second. So previously we had this kind of thing where we were drawing small texture, and let's say the texture was 1. And per that texture we had pipeline and texture as well, but then we had small amount of memory, which was our buffer, which contained basically our v1 data, v2 data for second vertex, v3, and v4. But then if we wanted to draw another entity, we also had, I'll just pass one for texture, but that was our player ship. If you imagine, so we had pipeline, and then we had this all over again, this small memory, v1, v2, v3, v4, then we had another one, right, same thing, small amount of memory which we drew, v1, etc. But with our sprite batching, we're not going to do this anymore. What we're going to do is we're just going to have, for example, our texture, our pipeline, and then we're going to have huge amount of memory here for v1, v2, v3, v4. So if you imagine that v1 is referencing this, right, v3. But what if we wanted to do another sprite? Well, since our memory is expanded, it's actually now going to draw another sprite here. And we might continue with v5, v6, right? v5, v6, v7, but that's kind of 7, and then v8, all right? And then further, right? And our renderer is going to go to somewhere to, let's say, well, it will support 1000 vertices, so times vertex, so it will be for, this is 1000 times 4, 4000 vertices. Anyway, it's not important. That's not important. The important thing is we're going to have huge buffer, which will have a lot of data here. So let's do just that. And how it will look like? Well, first of all, let's start with the index buffer because that's the easier one to adapt. So, and because index buffer is not going to change. So let's start with that. And how this works is we had our sprite render and we had these coordinates, and we can just now expand it, right? If we remember, our index buffer looked something like this. Let me just see this. So we had, let's say 0, 1, 2, that was our first triangle, and then we had 2, 3, 0. So 2, 3, and 0 again for our second one. But how do we expand it? Well, we're just going to go further and then 4, 5, 6. So we might have a second image. So well, basically second sprite here, and then indexes are going to be 4, 5, 6 for the first triangle, and then 6, 7, 4 for the second one. So 6, 7, 4, etc, etc. So if we wanted to do this one, it's going to be 8, 9, 10, and then 10, 10, sorry, 11, 8. Anyway, you get the idea. So let's just expand it, and how am I going to do that? Let me take a look at the notes. So I had a small method. I'll just expand this. I had a small method, private setup index buffer. And here, so what are we going to need? So we're going to change, we're going to have uint16. And let's just do here some constants. So we're going to have max number of sprites. That's per buffer. So that's maximum number that we're going to have in a buffer. Maximum or per call as well. And then we're going to have this const indices per sprite, and it's going to be 6 or 2 triangles per sprite, as you can see here. So here we're just going to say max number of sprites time indices per sprite. So we have our big buffer now, and now we just need to fill it with data. And how do we do that? Well, we just go to the max number of sprites, and then we need to write through each iteration 6 times. So we can say data I times indices per sprite plus 0, because this is just for 0. And then we can see I times 4 plus 0. Why? Because it's 0 here. So this one is going to be similar. It's just 1 here, and here it's 1 as well. That's for the first triangle still. Then 2, 2. So this is T1. And let's have T2. So we need to be more careful with this one. So these parameters remain the same. These are sequential. 5, 6. Sorry, no, wrong. 3, 4, 5. I did that error in WebGL series. So be careful. And then we had 230 here, so we need to hit 230, and you can see it's multiplied by 4, and that should fill it. So that should fill the data. And here we're just going to create the index buffer with that data, and that's it regarding this. Why is it complaining here? Oh, would you look at that? And then instead of setting this up like this, we can also remove vertices buffer. We're not going to use it like this anymore. I'm going to discuss it in a second, but this covers our index buffer. So you can see it will be able to hold 1000 changes. We can change that constant later. That's why it's constant. But now let's see further. What do I need? So we're going to need some way of storing the vertex buffer, because vertex buffer, whenever we change sprite or we want to draw more than 1000 edges, we're going to need more vertex buffers. So let's see how are we going to do that. And for that I might just create some small class. I'm going to call it export class batch draw call, and it's going to be simple class. It's going to have constructor. So it's what is this now? It's going to have our pipeline, and we're just going to pass our sprite pipeline to it, and then actually I can just put this here. It's going to have vertex data, and that's a new floater to array. So we're going to have max number of sprites, but we need some more constants. If you remember, our vertex float per vertex is 7. If you take a look at here, it's 7 entries, right? 2 for position, 2 for UV coordinates, and then 3 for colors. So its float per vertex is 7, and then I'm just going to create another constant, which is floats per sprite, which is 4, right? Because we have 4 corners, and then times floats per vertex. And now I can use this floats per sprite for this data here. So we need to make buffer, well, this big, and then we're just going to have public instance count is 0, and that's the number of well, that's basically a number of sprites that we're going to draw for each of our pipelines. And if you remember, we had one pipeline per texture. Anyway, it will all make sense once we start working on next part. And next part is actually optimizing these calls. So let's see what I can move here. Well, I can move this texture. We only need to set up camera, well, basically once per frame, or not even that. We could just set it on initialize, but it's fine either way. It's not going to drag performance down that much. Then here we need to refactor this part because it will now come from our object here, and let's just create this object. So let me think for a second, what am I going to have here? So I'm going to have, whenever we change a texture, we're going to need new batch, right? Because our batch, while we can draw many sprites, we can draw many sprites once per texture. You're going to see it, but let me just do these pipelines per texture. So here it's going to have ID is string, and then we're going to have sprite pipeline. Let me just see something. So our text, how are we going to get this ID? Well, if you remember, we had texture somewhere here, so we cannot use anything for ID. So let's just expand this by public ID, and let's say not number, it's actually string. So what can we use for ID? Well, we can make something smart here, but we can also just say image source. So our key is going to be, well, basically route that we used. Sorry, not img, it's rather image source. So that should work fine. And then let's get back here. So not sorry here, sprite render now. Okay, alright, we're going to need that. Then I'm going to also have private batch draw call per texture, which is similar, but it's going to have batch draw call here. So pipelines created for each texture, redraw calls per texture. Okay, that's good. So next what we're going to need is to have something called allocated vertex buffers. We're actually going to cache them. That's why I'm doing this. So idea is not to create vertex buffer every frame, rather we're going to keep some cache of it. And use for vertex data. Anyway, it's kind of a cache system. So next, I'm going to need private connect texture is of type texture. Okay, alright. Now the fun part begins. So whenever we change a texture here, if this current texture does not equal to texture, we need to do something, and that's let's see. Let's first assign texture. Then we're going to need pipeline. So we're going to fetch pipeline from a texture. But if pipeline doesn't exist, so that's caching. We're just caching so that we don't create an object every frame. So if our pipeline doesn't exist, we can create one and then add it to our pipelines per texture cache. That's fine. So here we're going to need to handle nothing yet. So we're good there. So we don't need to do this actually, right? But we had our batch. So our vertex data will no, we're no longer going to have this global vertex data. It's actually in our batch draw call. So let's here just fetch our batch. If it doesn't exist, we can just set a new batch draw call, and we're going to use our pipeline per texture, and then we can just add it, right? The same that we did for texture, we're just going to cache it so that we don't create it as well each frame. So here we're going to have and then floats per sprite. And here we can just say, instead of this, we can say batch draw call. So let's do this. Actually, you can do it like this. You can find this F and then place this and replace it everywhere. So that's fine. But here we're actually going to use this I. Now I'm going to explain everything in a second a bit. Plus I. Really boring part. Okay, did that. So now, here, somewhere over here, we're just going to say batch draw call instance count plus plus. We need to increase this instance count. We don't need this. And here do nothing, and we're just going to cut this and then call public and probably frame end. So once we're done with that, we're good. And here, so now here we need to make use of our draw calls basically. So we can do this for each of the batch draw calls. Can I do this? I don't remember the syntax in TypeScript for that, but anyway, let's just fetch our batch draw call, and we're going to use that draw call. And here, what was it? We can actually move this here as well. I forgot about that. So that needs to be set up once, well, basically per frame, and then, or even once in the whole app. It doesn't need to be per frame because we don't change camera that often. But here, if our instance count is 0, we don't need to do anything. We can just continue. So there is nothing to draw. If we do have it, so we need to fetch our sprite pipeline. And our sprite pipeline is in our batch draw call. So we fix that. We're almost done. Only thing left is our vertex buffer. Oh, it doesn't exist. It's pipeline. Sorry. So only thing that we need to do is somehow get this vertex buffer, and here we actually need to multiply times instance cost. Why? Because we are actually drawing more indexes. If you remember, I mentioned this v0, v1, sorry, no, 0, 1, 2 triangle, then 2, 4, 0, and then we were going further up to 8, 9, 11. This is this part, right? We're going to draw maximum of 6,000 indices. Anyway, not important. So let's see further. So how are we going to actually get this buffer? Where I'm going to create, we're going to use these allocated vertex buffers, and here I'm just going to have some small call, which is going to be, sorry, small method used vertex buffers. And the ones that are used are just going to go in our, at the end, vertex buffer of use vertex buffer. We're just going to add it to this allocated vertex buffers for now, but we're still not allocating anything, and we're actually going to allocate now somewhere over here. So we're going to say vertex buffer. So just to explain how it will work, let's first write it. So we're going to check from allocate vertex buffer. If there is no vertex buffer, then we actually need to do this. We need to create it. We're going to create it with our batch draw call data. So our data from here, right? So that's what we fill in. And then, actually we don't even need to fill it in. Yeah, we do, but if it doesn't exist, we can just say here else we have it, and then we can just write to it. So we can say this device q write buffer vertex buffer, and then we can write to it. So either we're going to create it, so it needs to be created once if we don't have it, but otherwise, sorry about this, otherwise we can just write to existing one, which we got from our allocated vertex buffers. And here in used vertex buffers, we're just going to push it. So that we know it was okay, it was used, we need to push it to allocated ones. So it kind of works like this. So here, so we want to draw something, but we need a buffer, right, for this draw call, which might have this bunch of sprites. So we need a buffer, and here let's imagine that these are our buffers. So whenever we need one, we pop one from the stack, and our stack now has one less. Actually, this is terrible. Let's do this a bit simple. Let's say that we just have two buffers, and we need one. So we pop one from the stack somewhere here, and our stack now only has one. So if we need this one, we also pop it from the stack. Our stack is now empty. So when it's empty, we actually need to refill that stack, and we do that just here. Maybe I should move this a bit. So we do that just here. We create a new buffer, add at the end. We just push it here for temporary. So this is just some temporary variable, just so that at the end we can refill our stack. So we're done. Let's say this one is done. So he's going back to stack. This one is done. He's going back to stack. Anyway, kind of bad drawing, but you probably get the idea. So the main takeaway is we need to have our batch draw call, and the batch draw call will actually it's just a placeholder class where we fill the data, and then we can use it here. Maybe I should probably explain. Let's see it in action. Let's see it in action. It's a bit weird. It is what it is, but let's see it in action. So it doesn't work because I haven't called end. Okay, this was easy to catch. At least I haven't wasted any time. Okay, so now you know that it's broken, and I need to see why. I probably because at the beginning I forgot to clean stuff up. So we somewhere over here we had sprite render, and then we have this frame pass, but here I need to clean up everything. So I'm just going to say lazily this bedrock. So I'm just going to reset this thing. Okay, now it's working. And if I take a look here, if you remember, when we started, where are you? WebGPU. So if I just restart it, it has the bug point. So you can see now we don't have that many buffers, but that's not interesting. So important thing is these draw calls. We only have two. If you remember previously we had 20. So this is important part. This is really important part. So this is what really gives us, well, that kind of performance, because we have less draw calls. And in main, if I now do this, for example, 1000, you can see here we're drawing really lots of sprites, but the performance is 60 frames per second. So if I am to increase that buffer size, let's do that. 10,000. I can increase my entries to 10,000 as well. So it has some initial frame rate dip, but otherwise it looks good. It's near constant 60 FPS with 20,000 sprites on screen. So if I'm just to resize them, you're going to see how much of them do we have on screen. So we cannot even see anything. We cannot even see background with this amount of sprites. So that's how batching works. Although there is one small issue here, and that issue is what if we have 10,001? So what if we go over our buffer size? Well, everything kinda breaks, right? So we need to fix that issue, and so we can just expand our class a bit here, where we had sprite render to take that into account. So instead of having single batch draw call here, we're going to have array. Okay, we're going to need to have array. This is going to be simple, not that many. So here we need to actually initialize this batch draw call. So let's say let's do this check. Opa, not cut. Let's do this. But if there isn't, as we can actually call this calls because it's an array now, right? Here it should return array of batch draw calls. So here we're just going to say this batch draw calls per texture ID, and we're going to initialize to empty array. There isn't any. And here, since we're actually now working a bit differently, we can ask here for last entry instead. So let's do just that. Let's have actually batch const array of batch calls. So we're going to fetch that array that we have now, and then we're going to get this batch draw call from our array. So array of batch calls, and then we need the last entry. So we're just going to get the last entry. And if there isn't last entry, we actually need to add it. And how am I going to do that? Well, it's really simple. So we can just say here now push, so that we have it in array. That's perfect. Let me just format this thing a bit. And finally, here, what's important is we need to take if there is more instances than we can draw, which is causing this error. We can check if this instance count is greater or equal than max number of sprites. Then we're just going to create a new batch. And then we're just going to push it to our draw calls per texture. And then here we actually need another loop. So this is now calls or array of batch draw calls. So we need to loop through that array. How do I do that? So we can say here const batch draw call in array of batch draw calls. We're going to use that array instead. Let me just do this as well. String off. Sorry, my bad. And that should kind of cover it. For some reason it doesn't. So it means we have a bug somewhere. Probably some smaller bug. This should be restarted though. If I do minus. So what's our instance count? It should have 1000 maybe. Just my math is not on par. So let's see our first one. Oh, come on. 10,000. Okay, that's alright. That's alright, I think. Greater or equals. Aha! Okay. Alright. We don't need this -1. We actually increase here. Okay, now we're good. So perfect. That was it. Hopefully you figured out how this thing works. And now here we can even increase this quite a bit, and it's still going to work without any issues. So if we say this, it still works 60 frames per second, which is perfect. And even if I do in our sprite render, I can draw on the lesser, well, like I can decrease our instances. It still works. It has some dips here, as you can see, but it really we're now rendering well 40,000 entries, which is perfect. So that's it for this video. Hopefully you see the benefit of sprite batching. So the sprite batching in general, it just means really to lower those row scrolls and to draw instead of drawing and every sprite one by one, you actually draw, let's say, 100, 1000, 10,000 sprites at once. So that's what sprite batching is all about. In the next video, we're actually going to make use of this, and we're going to basically cover uh, going to cover sprite sheet. So we're going to make use of these coordinates and then learn how to actually use sprite sheet as well. So that's it for this video. Hopefully you enjoyed it. If you enjoyed it, click like, subscribe, and until next time.